Hello all. Alright, so before we get to talking about the threat for a snowstorm next Tuesday into Wednesday, I just want to talk briefly about another threat that's going to happen before that. That is in between threats 2 and 3. I'll call it threat 2.5 for kicks. Why not? Here we go. So, I'm going to go back here. So this is the Canadian model, and this is the only model that's really showing this much of a threat. This is your wind map, your 500 millibar wind map. Here we go. This is your piece of energy that's going to be coming in Sunday into Monday. Well, Saturday into Sunday, excuse me. And what the Canadian model is showing, none of the other models are showing this, is it has another piece of energy back in here along the southern jet stream. So you have your northern piece of energy and a southern piece of energy. What the Canadian model is saying is that these two pieces of energy are going to combine, like so. See that? Just a little bit. They don't really get too attached to each other. And then what happens is you get areas of low pressure to form here, and then you get a bit of a storm in the southern region here. So if you look at your precipitation map, you can see that there's some precipitation back into this area here, starting back in Oklahoma and Kansas and then spreading east-northeastward. Now, I'm going to show you something. This is your air mass map this is from the American model. Alright, so if you look at Sunday during the day and into Sunday evening, behind the weekend storm, this big Arctic air, this strong surge of Arctic air is going to be working in. And it's going to be as far south as the Carolinas, and then back into sections of Tennessee, and into sections of, I believe that is Missouri. Don't take me up on that. I'm not good with these states back here. And then up into Nebraska. So it's coming pretty far south. So this whole area is going to be immersed in cold air by Sunday night. Now, taking a look at your Canadian model here, what I'm worried about, this piece of energy, if you have a storm forming, that you might get some snow back into here from anywhere from southern New Jersey, Maryland, Delaware, extending southward across West Virginia, maybe into Kentucky, and then I'll take the threat back down into Arkansas and maybe into sections of Oklahoma. I think it might be too warm down here, and I'll bring it back across Tennessee and then into sections of North Carolina perhaps for Sunday night into Monday. So it's another threat to watch. I don't think this is the biggest threat that we need to be watching, but it's there. So you might need to watch out for some snow in this area. Again, if the other models start to show something, which they aren't right now. In fact, the other models aren't even showing a second piece of energy down here. Only the Canadian model is. I don't know what's up with that. But the big threat that we're concerned about after this leaves, you get a big surge of Arctic air coming in behind that. You have all these areas of high pressure setting up. You get a big surge of Arctic air. Every model is showing that. Then what you get is you get these two pieces of energy coming on in. Piece number 1, piece number 2. Okay? Now, what happens, I believe, and again, I'm new at this, so my interpretation might be a little off. What's going to happen is the difference between the American and Canadian, the American and Canadian are the same, and then the European is different. The difference between the models here, the American and Canadian have this piece of energy in front of that piece of energy. Okay? This second piece of energy comes in behind the first piece. The European model has this digging further south, and then this piece coming on top. And so they combine earlier, you get a negative tilt earlier, and it moves northeast a lot earlier. That's the difference. Now, according to the American and Canadian models, if these two pieces of energy are, in front, or this is in front of this would be more of a progressive type of system, and it would move more to the east before it starts to shift northeast, because these two would come together just a little bit later. Okay, so that's what I'm seeing. So let's go ahead here. Okay. You see that? It stays in front, and they combine later. And look how far north they're combining, too. Now, here's another thing about the Canadian model that I don't get. If you have pieces of energy over here, and they're combining here, and you have a big temperature difference. And then you have, why would you have high pressure there on Tuesday? That to me doesn't make sense if there's supposed to be a storm forming. The Canadian model, this run really confused me, so I really don't think this is the correct solution. Anyway, those two pieces of energy do come together, but it stays pretty much in front. Then you have this big piece of energy here. That now the Canadian doesn't even have a low area of low pressure forming with this first piece. Second piece is where the area of low pressure forms, and because of that, your storm comes in a lot later too. So this is the second piece of energy, and you see you have two areas of low pressure, one back here, one down here, and your precipitation, you can see, is generally light. Nothing really happens. There's not really much of a storm going on with the Canadian model. Alright, so then again, that's what they're showing here. That's the Canadian. American model is a little bit different, and you have a big surge of Arctic air coming in behind, don't forget that. Did they update this? Nope, they did not update the 18Z run of the GFS yet, so we have to use the 12Z. Okay, we're going to go to 384, so I can show you a comparison between the European and the American. Okay, so we're just going to go straight to it, but first, just to show you, here we go. This is the Monday system. And again, I don't see a southern piece of energy here like the Canadian model is showing. So my thinking is that if you look at your precipitation map, you wouldn't really get that much snow in here for Sunday night into Monday. So again, the Canadian model again is confusing, so I don't know if it'll be right. But Sunday night into Monday, we'll keep an eye on it. If something changes, I'll post an update about it. Now, alright, here we go. This is Tuesday. So you see this? This is actually your second piece of energy right up there. This is your first piece of energy back in here. These two are going to shift, and they're going to come around south and east. That's a little bit too far, sorry. Here we go. So watch how they shift now. Now, as of now, you see how the second piece is on top of the first piece pretty much? Well, that's not going to last. Now your southern piece is down here, but your second piece is, rather than being on top of it, is behind it. So that was at 144. Watch the European. Here we go. You have a piece of energy up here, and this digs further south. So this is more. It's closer to. It's more on top of it rather than behind it. So here we go. And again, these two do come together with the American model. But also, the other difference behind it, also, the European model has another section in this region here that's a lot stronger than what the American model is showing. And the Canadian. Alright, so up in here, not only does the European have these two pieces of energy combining, but it also has another piece of energy up in here dropping down into the southern piece as well, making it a lot stronger. So let's take a look at that. So here's the next run again. Again, you can see there wasn't really anything up here dropping down. See this? The difference between that and this. So pay attention. This area here compared to in the European, you see how that piece of energy is stronger. This is more, it's further south as well. It's more on top of this piece. And the other thing I want you to pay attention to, alright, so number one, also pay attention, this is further south than in the American model. You see that? Not by much, but it's still a pretty big difference. Notice the tilt. This is more of a negative tilt to this trough here. On the American model, excuse me, it's more of a positive tilt. So it's more of a positive tilt. It's not more of a negative tilt. And this second piece of energy is way further behind, like I said, than in the European. Okay? So positive tilt, negative tilt. That's the difference. Another difference. So there's a few differences. So then watch this. So this piece of this northern piece of energy drops down into here. This second piece of energy combines. All of this comes together. And bam! Look at that. This is a really potent negatively tilted trough. So bam, this is a pretty big storm now. Look at this dark red over here. That's pretty strong. Now the American model. Here we go. See, you can kind of see it's weaker if you zoom in, like I'll show you here. You see, this is a lot weaker now than in the European. Hold on, here we go. So pay attention to that outside piece there. See how it's stronger? And it's closer together. So you see, this piece and this piece back in here, the European brings them together, which is why you get this big piece of this big blob right here. So everything comes together. In the American, it's more separated. Okay? So again, that's the difference. So now watch this. This is your low pressure map for the American model. Look at how far south that is. On the European, look what it has. Look at the difference there. American, European, American, European, American, European. Okay? So you can see, number one, this is further north because everything came together. That northern piece of energy kind of shifted it north just a little bit further. And again, so then look at how much stronger that is because everything came together. The American model did not show everything coming together. It kept most of that stuff separated. And then look at the track of this storm. It starts down here and moves up the coast like this. Look at where this is. If you want a big snowstorm along the East Coast, this is the perfect low track right there. Perfect. You could not ask for a better track of the low pressure than this if you want to get heavy snow back in, this area here. So it's perfect. The European model is the perfect storm solution right now. American model is not, neither is the Canadian. American model says no. Energy is not going to come together. It's going to stay separated, and you get a further south solution. Okay, and watch. That's 1,000 millibars. You see all these bars around here? I couldn't read this, so I had Bernie Rayno at AccuWeather tell me what the central pressure this is here. 976 millibars. That is pretty low for a storm. That means that it's rapidly strengthening from. When it's down here, it's 1,008. This is your storm. It's 1,008. When you come up here, that is a big jump in strength. That is what we call bombogenesis. When the central pressure of your storm drops 24 millibars in 24 hours, and it's dropping a lot more than 24 millibars, I'll tell you that. It's dropping by about 32 millibars, not 1,008 to 976. So, again, because that piece of energy digs further south than the European and everything comes together, this is your perfect storm solution. Bam, right up the coast. Perfect. That's what we want. Well, that's what I want. That's the difference. So, I think I explained that well. So, here's your threat area. I'm going to do this really quick. Anywhere, northern New England, Maine, I'm putting you in this. Extending back into New Hampshire, Vermont, back into western New York, Pennsylvania. We're going to cut across central Pennsylvania. We're going to go back into West Virginia and back into Kentucky because it starts to form down here. And then we're going to go across North Carolina and then northern portion of North Carolina. I don't know if it'll make it that far south. And then going all the way back up the coast here. New Jersey, you're in it. Maryland, Delaware, you're in it. Washington, D.C. and Philly, you're going to be in it as well. On the southern edge, again, you have Long Island, New York City. You're going to be in it, definitely. Boston, you're in it. Bangor, you're in it. So all of these cities are definitely going to be in it. Pittsburgh, I'm not sure about you yet. I think you could be on the western edge of this threat. And Baltimore, you're definitely in it as well. Philadelphia, you're definitely in it. And again, if this comes close to the coast, we're going to have to watch for mixing. But hopefully it does not. That colder air will be working in. All right, I'm done for today. We'll be back tomorrow.